During this lecture, we will learn about soil texture, and based on that, we will categorize the soil into different classes. First of all, let us get an idea about the general meaning of soil and its composition. Soil is the thin layer on the surface of the earth on which the living beings survive. Soil is made of diverse materials like weathered rock particles, decayed plant material and animal matter. Not only this, soil also contains microbes. In this layer, various plants have their roots. Soil is considered as a very precious material because it takes more than 1000 years to form a thin layer of soil. We can find an enormous diversity of soils across the world. Let us see various factors influencing the composition of soil. Soil formation and soil types are influenced by several key factors like parental material, usually rock or sediment, organic materials such as peat, climate, particularly temperature and precipitation, vegetation and other biota, topography and increasingly the influence of humans. All these factors will have an influence on soil development and hence soil type. The potential for different combinations of these factors across the world is immense, and hence it is not surprising that there are many thousands of different types of soil in the world with different properties and potential. Now, we will learn about different soil classification systems. There are many soil classification systems. The two major systems include the vernacular system and scientific system. Vernacular system is developed by land users. For example, in vernacular system, soil can be categorized as red soil, black soil, yellow soil, hot soil, etc. In scientific systems, the soil can be categorized according to the development of soil or the amount of substances present in the soil. However, mostly classification of soil is based on the size of the particles it contains. It is also referred to as soil texture classification. This classification helps to understand the basic properties of the soil and helps to conclude if the type of soil is good enough for gardening or farming. Before classifying the soil into different types, let us understand the concept of soil texture. Soil texture is a qualitative classification tool used in both the field study and laboratory to determine classes for agricultural soils based on their physical texture. The soil classes are distinguished by separating the relative proportions of sand, silt and clay using grading sieves, also known as the particle size distribution, that is called PSD method. The soil class is then used to determine crop suitability and approximate response of the soil to environmental and management conditions such as drought or calcium requirements. This quantitative tool is a fast, simple and effective means to assess the soil physical characteristics. Generally, soil is made up of finely ground rock particles grouped according to size as sand, silt and clay. Each size plays a significantly different role. For example, the largest particles like sand determine aeration and drainage characteristics, while the tiniest submicroscopic clay particles are chemically active, binding with water and plant nutrients. Soil textures are classified by the fractions of each soil separate like sand, silt and clay present in a soil. The ratio of these sizes determines the soil type. Clay, loam, clay loam, silt loam, and so on. Determining the soil textures is often aided with the use of soil texture triangle. Classifications are typically named for the primary constituent particle size or a combination of the most abundant particle sizes. Example, sandy clay or silty clay. The term loam is used to describe a roughly equal concentration of sand, silt and clay, and leads to the naming of even more classifications. Example, clay loam or silt loam. As shown in the table, soil separates can be categorized as per the differences in their particle size. According to USDA classification, the clay particles have diameter of less than 0.002 mm. Silt particles possess diameter of 0.002 to 0.05 mm. Very fine sand has the particle size of 0.05 to 0.1 mm. Fine sand particles are having the diameter of 0.1 to 0.25 mm. Medium sand particles have the diameter of 0.25 to 0.5 mm. The diameter of coarse sand particles is 0.5 to 1 mm, while the particles with the diameter of 1 to 2 mm are categorized as very coarse sand. In addition to the mineral composition of soil, humus also plays a crucial role in determining soil characteristics and fertility of the plant life. Both organic and inorganic materials are combined with soil to achieve a good mixture suitable for the plant growth. As the composition of both components change over time, different types of soil textures are formed. Now, let us study the various causes and consequences responsible for the formation of various types of soil. Basically, there are different types of soil depending on the soil texture, and each type exhibits certain characteristic properties. Each type of soil has a specific texture, color, water holding capacity, etc. Based on the size of particles present in the soil and composition of the particles, soil is classified into various types. First of all, we will discuss about the formation and properties of sandy soil. Sandy soil is mainly formed due to the transportation and weathering of rocks like quartz, limestone and granite. It is a granular and its formation consists of small rock and mineral particles. Sandy soil has the largest particles among the different soil types. It is dry and gritty to the touch. When slightly wet sandy soil is rolled in the palms, balls are not formed and it crumbles through fingers easily. It is very porous, with large spaces between soil particles. Aeration of sandy soil is high and water holding capacity is very less due to its gritty texture. Water drains rapidly straight through the places where the roots, particularly those of seedlings, cannot reach. Plants do not have a chance of using the nutrients in sandy soil more efficiently as they are swiftly carried away by the runoff. This type of soil cannot hold water for an extended period of time, so it does not have a hydrating effect. Sandy soil retains a certain amount of moisture and nutrients. Sandy soil is great for plants which requires less water as it let the water to go off and does not let it stand near the roots and lead them to decay. This type of soil is ideal for vegetables, bulbs, annuals and a large section of conifers. Sandy soil consists of large spaces in between soil particles, so it provides a better drainage. Little water is retained and the sandy soil dries out quickly. This over drainage causes the plants to dehydrate in the summers. To keep the plant healthy and growing in sandy soil, regular watering is recommended. The next type of soil is silty soil. Silty soil is considered to be one of the finest and most fertile soils on the earth. Let us know the basic composition of this type of soil. Silty soil consists of materials like quartz and other fine organic particles. It is granular like sandy soil, but it has more nutrients and better water holding capacity than sandy soil. Texture of silty soil is smooth when dry and looks like dark sand. When it is rolled between the fingers, dirt is left on the skin. Silty soil can withhold more moisture and at times becomes compact. Due to its moisture retentive quality, silty soil is cold. It also offers better drainage and is much easier to work with when it has a moisture. Silt soil can keep water for a longer time and it can maintain a good type of dampness ideal for a plant to thrive. The soil is also more nutritious as compared to sandy soil, although clay soil can compete with its nutrient levels. While not all plants can thrive well in silt soil, it does present a better alternative compared to sandy and clay soil. The third type of soil is a clay soil. This kind of soil is formed after years of rock disintegration and weathering. It is also formed as sedimentary deposits after the rock is weathered, eroded and transported. Clay soil, due to its formation process, is rich in mineral content. Clay is a kind of material that occurs naturally and consists of extremely fine grained material with very less air spaces. It is sticky to the touch when wet but smooth when dry. Clay soil has good water storage qualities. Because it is slower to drain, it has a tighter hold on plant nutrients. Clay soil is thus rich in plant food for better growth. As its drainage capacity is very low, there is possibility for water logging to occur, which can harm the roots of the plants. Clay soil becomes very heavy when wet, and if cultivation has to be done, organic fertilizers need to be added to the soil. The next type of soil is called peaty soil. Let's get an overview of the process responsible for the formation of peaty soil. Peaty soil is basically formed from the dead and decayed organic matter. Peat soil started forming over 9,000 years ago with the rapid melting of glaciers. This rapid melt drowned plants quickly and died in the process. The decay was so slow underwater that it led to the accumulation of organic area in the concentrated spot. The amount of organic matter contained in it is far more than amount of organic matter present in other types of soil. This kind of soil is mostly formed in wet climate and is found in marshy places. Peaty soil is dark brown or black in color, is soft, easily compressed due to its high water content and rich in organic matter. It is spongy to touch and when squeezed, water can be forced out. The most desirable quality of peat soil is its ability to hold water during the dry months and its capacity to protect the roots from damage during very wet months. Peat contains acidic water, but growers use it to regulate soil chemistry or pH levels as well as an agent of disease control for the soil. Though the soil is rich in organic matter, nutrients present are fewer in this soil type than any other type. Peaty soil is prone to waterlogging, but if soil is fertilized well and drainage of soil is looked after, it can be ideal for growing plants. Now let us get an idea of the other type of soil referred to as a chalky soil. Generally, chalky soil is very alkaline in nature and consists of large number of stones. It is light brown to white in color. This sort of soil is very much prone to dryness, and in summers it is poor choice for plantation as the plants would need much more watering and fertilizers as compared to other types of soil. Besides being dry, it also blocks the nutritional elements like iron and magnesium from reaching the plants. This may cause problems with some plants, causing the leaves to become yellow, leaf loss and loss of the entire plant. It requires fertilizers, compost and manure as additives to improve the conditions. The fertility of this kind of soil depends on the depth of the soil, that is on the bed of the chalk. Vegetables and a large array of perennials can thrive in chalky soil. Out of all the previously described soil types, the most important kind of soil is considered as the loamy soil. Let us discuss the main composition and properties of this type of soil. Loamy soil contains a balanced mix of sand, silt, clay and organic matter. Loamy soil is generally loose and looks rich. The texture is grainy and retains water very easily. Still, the drainage is well. Loamy soil can be sandy or clay based and will vary in moisture absorption and retention accordingly. It has a higher pH and calcium levels because of its organic matter content. Loam is dark brown in color and is mealy, soft, dry and crumbly. When squeezed in fist, moist loam will form a ball which crumbles when poked with a finger. There are various kinds of loamy soil ranging from muddy to fertile soil. As this soil consists of sand, silt and clay in specific composition, it is considered to be the perfect soil for cultivation. This soil provides a wonderful structure for roots. The sand part of loamy soil gives it good ventilation capacities, while the clay part keeps the moisture in place. Thus, loamy soil can actually provide good ventilation and moisture at the same time. Loamy soil is very good for gardening because it can be used for growing almost any type of plant. At last, let us have an overview of the different types of Indian soil characterized based on the composition and geographical location. Basically, there are 7 types of soil found in India. The first type of Indian soil is alluvial soil. This includes the deltaic alluvium, calcareous alluvial soils, coastal alluvium and coastal sands. It is the most important soil group of India, contributing the largest share to its agricultural wealth. This soil is derived from the deposition laid by the numerous tributaries of the Indus, Ganges and the Brahmaputra systems. Geologically, alluvium is divided into khadar, generally light colored sandy soil, and bhangar, generally dark and full of kankar. This soil is rich in loam and clay and is considered as the fertile soil. The second type of Indian soil is black soil. The soil varies in depth from shallow to deep. The typical soil derived from Deccan Trap is the Regur or black cotton soil. It is common in Maharashtra, western parts of Madhya Pradesh, Andhra Pradesh, Gujarat and Tamil Nadu. This type of soil possesses black colored fertile clay. Red soil is the third type of the soil found in India. The ancient crystalline and metamorphic rocks on the meteoric weathering have given rise to the red soil. The soil is sandy to loamy. The red color is due to the wide diffusion of iron in the soil. They are poor in nitrogen, phosphorus, lime, potash and iron oxide. The soil comprises vast areas of Tamil Nadu, Karnataka, Goa, Daman and Diu, Madhya Pradesh, Odisha, Jharkhand, Bihar, West Bengal, Uttar Pradesh, etc. Another type of Indian soil is lateritic soil. It is a formation peculiar to India and some other countries. It is a mixture of hydrated oxides of aluminum and iron with small amounts of manganese oxide, etc. These soils are poor in lime, magnesia, nitrogen, potassium oxide, but humus and phosphorus pentoxide is high. This type of soil has greyish red color. The next kind of Indian soil is called problem soil. These are the soils which, owing to the land and soil characteristics, cannot be economically used for the cultivation of crops without adopting proper reclamation measures. Besides these classification of soil, the next popular classification of Indian soil is according to the pH level of soil. Soils have pH below 7 are considered to be the acidic, but those which have pH less than 5.5 and which responds to liming may be considered to qualify to be designated as acid soils. It occurs widely in Himalayan range, Gangetic Delta and Peninsula. In this classification, soil can be either acidic soil or alkaline soil depending on the amount of humus, organic matter and the underlying bedrock. But no matter what the type of soil is, every soil has its own advantages and disadvantages. There are various plants that have different requirements because all plants do not need the same kind of soil.
In this part of lecture, we have got the information regarding two different types of soil classification systems. Today we have learnt that vernacular system is developed by land users while the scientific system is designed on the basis of classification of soil particles according to their size. We have also studied soil texture in detail. During this lecture, we have mainly focused on different types of soil. We have discussed sandy soil, silty soil, clay soil, peaty soil, chalky soil and loam soil in relation to their specific characteristics, especially soil texture, water holding capacity and fertility. At last, we have also learnt about different types of Indian soil.